I'm going to get started right away with number one. We've got $4,500 invested at 10.5% compounded monthly. Then the future value of the investment, S, after X years, is given by that equation. We're asked to graph the function in GeoGebra, analyze the slope over time, describe how it's changing, and what is happening. So remember, we don't need to submit the graph for this one, even for the real test. We just need to describe what is happening. So if you watched if you watched the video for practice exam 1, my explanation here is going to be very similar because basically the same thing is happening, and we'll sort of beat this dead horse for quite some time because it's an important idea. So here in the beginning, we have a relatively flat slope, not super steep, not super flat also. But as we go out and look at this over time, like here from 0 years to about 10 years, it looks like it went to about $12,000, and so it went from 4,500 to, let's say, 12,500 to make numbers easy. We gained $8,000 in the first 10 years. The next 10 years, from 10 to 20, we did not gain $8,000. We would go from about 12 to about 36. So 10 years later, we have gained about 24,000. And so 8,000 in the first 10 years, 24,000 in the second 10 years. If we go all the way over and look at the next 10 years, we would see that it's going up a huge amount. It ends up over $100,000. And so this goes from about 35,000 or so, something like that, to over 100,000. So the next 10 years produces a gain of over $30,000. And so it's an important idea to understand that the longer an investment exists, the faster the money in it grows. And so let's take a look at what the question was again, just to make sure we got it. What is happening to the investment over time? The older the investment gets, the faster it grows. And coming down to part B, we have, let's pretend that this $4,500 was put into an account to be used toward purchasing a car for a child on their 16th birthday, on the day they were born. What would the value of this fund be on the child's 16th birthday? So we can kind of use GeoGebra to guess what that might be here. Let's take a look. We'll get the graph so it's showing a reasonable picture here. And so it looks like this $4,500 in this instance would grow by the time the child is 16 years old to be somewhere in the neighborhood of $24,000. And that would buy this kid a pretty nice car. So let's go ahead and swing that in Wolfram, everyone, and see exactly where this fund would end up in 16 years. We're guesstimating somewhere in the neighborhood of $24,000. And we almost hit that exactly on the head, everyone. This is going to grow to be $23,969.21. So when the child turns 16, the $4,500 has grown to be $23,969.21. And so we get a pretty huge amount of growth here, everyone. This investment's gained almost $20,000 in the 16 years that it's been invested. So let's move on to the next part C. If the child were to decide to save the money and drive her parents' old car, leaving the investment intact, how much would she expect to be in the fund on her 30th birthday? And how about her 65th birthday? What is happening to the value of this investment over time? And so let's go ahead and put 30 in here, everyone. And we will see that in 30 years, the value of the investment reaches $103,583, and that's enough to buy a decent little house. So when the child turns 30, The $4,500 has grown to be $103,583.29. So over the next period, so again, from going from 16 years to 30 years, we only added 14 years to this. And in that 14 years, we've gained about $80,000. So making $80,000 in 14 years for doing absolutely nothing, that sounds pretty good. We're going to go ahead and also figure out how much money would be in this investment. What would happen to this $4,500 if the child left it in there from the day they were born to the day they retire at age 65? Let's see what happens. And so you can see I do have a times 10 to the 6 over here. That means I'm going to move the decimal 6 places to the right. And I think this number is going to be a little bit stunning. So we get down to part D. Or well, we'll call it C part 2. So C2. All right. We have, if I move the decimal places 6 places, it's 1, 2, 3, 4, 5, 6. We have 4 million. So when the child turns 65, the $4,500 has grown to be 4,021,422.87. So that's pretty shocking to me, even. Having taught this class for several years and things, it's amazing that this $4,500, given a 65-year run, could end up being $4 million by the time that this child is ready for retirement. And so, as I've said multiple times throughout this section, everyone, this is how rich people stay rich. And this is pretty awesome stuff.